So guys, you are welcome back to this tutorial again. The last example we are going to revise is under statically indeterminate structures, and the question says calculate the reaction at the middle support of the continuous beam shown in the figure below. So this is the continuous beam. We have 2 meters from A to, let's say, C, and this is, maybe you can call it C. Okay, so this is point C and this is B. Okay, so we have A, B, C now. So the center is the C. We are asked to determine the reaction at C. So the reaction at C, we can call it RC, and this is RA or RAY, RCY, and here we have two, RBY and RBX. Okay. So when you have this type of when you have this a problem of this nature, the first thing is to what? The first thing is to make sure that this is statically indeterminate, and then you determine the redundancy, the degree of indeterminacy. Okay, you determine the degree of indeterminacy. So we know that normal reactions are 3 and in beams, so we have 3R, and let's confirm here, is this 3 or it is not up to 3 or more than 3. So we have one here. Okay, we have one here. This is also roller, we have one unknown. This is a pin support, we have one horizontal and one vertical. Okay, so we have two. That's 1 plus 1 plus 1 plus 1, which is 4. So which means we have 4 minus 3. 4 minus 3 is equal to what? Is equal to 1. So this is indeterminate, statically indeterminate to degree 1. Okay, which means we have one additional member which cannot be determined by the 3 equations of equilibrium. Okay, so since we know that we have one unknown member, for simplicity, you have to assign, you pick your redundant member. Okay, for simplicity, I will just pick the support C as the redundant member. Okay, I'll pick the redundant C, the support C as the redundant member. So taking this as the redundant member, when you are solving, the first thing is to what? To remove the redundant member. Okay, so if this is what we have, okay, I have removed the redundant member. Okay, so assuming this is what we have, so after removing the redundant member, we are going to have what? The span will change to 4 instead of 2. That's 4 plus 2 plus 2 is 4. Okay, so if you look at this, it's just like you have a simply supported beam, 4 meter span, and carrying a UDL of W kilonewton per meter, which is 10 in this case. Okay, so which means the deflection formula for this is already familiar. You know it. Okay, the deflection here, this is the deflection. We use delta here instead of y, but it's the same thing. You can use your yc or you can use your delta c. So delta c is equal to 5w alpha 4 all over 384 ei. This is the formula for simply supported beam carrying a UDL over the entire span. The deflection at the center is given by this formula. Okay, the negative is indicating that the direction is downward, so downward is negative in our case. Okay, this is where we have our delta C now. Okay, so from here now, you can, since you have your delta C, you can remove the external load. You remove the external load and replace your redundant member with a unit load. Okay, something like this. You remove the external load and replace your redundant member with a unit load. Okay, so we have a unit load here, 1 kilonewton. That's the unit load. We have a unit load here, 1 kilo Newton. Okay, so we have a unit load 1 kilonewton. So this is our unit load. So if you look at this arrangement now, it's like a simply supported beam carrying a point load at the center, but the point load is just in the opposite direction. Okay, it's just something like this. The point load is at the center. You see, so it's just the direction of the point load is going upward instead of downward that we are familiar with. Okay, so what is the formula for this? The deflection of a simply supported beam carrying a point load at the center is given by WL cube over 48 EI, and since the direction is upward now, in this case it is not, it is going upward now, the deflection is off, we leave it as positive. So you have FCC as equal to L cube over 48 EI. We remove the W because it is a unit load, so W is just 1. So you have your FCC now and you have your delta C. The next thing is just to use the compatibility equation. Okay, so the compatibility condition says, since we are considering the same point, then definitely the sum of the two deflections must be 0. Okay, so deflection at C must be equal to 0 with this arrangement, with the unit load at C and with uniformly distributed load over the entire span. Okay, so for that reason we are going to add the two deflections and equate everything to 0. Delta C plus FCC is equal to 0. But remember, we are not after just FCC, because what we have here in FCC is unit load, or W is unit load, but we are after the reaction. In the original cosine there is a reaction here, so you must multiply the FCC by the reaction. Okay, so after multiplying delta C plus RCY, which is our reaction at C, then which times the FCC is equal to 0, then we need to make this subject of the formula. So this is going to cross the equality sign, it changes to negative, divided by the coefficient of RCY, which is FCC. We have RCY to be equal to minus delta B or C. I think it's delta C, this is a typing error, so it's delta C over FCC. Okay, which is equal to delta C is 5W alpha 4 over 384 EI, minus will be positive, all over WL cube over 48 EI. If you have something like this, you apply your knowledge of mathematics. Okay, this is like you just take the inverse of this, you take the reciprocal and multiply it here. Okay, something like this, times, okay, sorry, times 48 times 48 EI all over L cube. You just take the reciprocal. Okay, so that L cube is cancelling this, it will cross the power 4 here, only one L will remain, and 48 is going into 384 8 times. Okay, EI and EI are gone, so we are left with 5WL all over 8. Okay, that is what we have here. We have 5WL over 8. So W is given, L is given. So for the L, you take the entire span, which is 4, 2 plus 2, which is 4. Then we have 5. Our 5 is in the formula. Then W is 10. 5 times 10 times 4 all over 8 is going to be 24 kilonewton. This is the reaction at C. So with this, you have come to the end of the solution. Or if you are asked to determine the reaction at A or reaction at B as well, then you use your normal equilibrium equations. You take moment at either A, B or C, then you sum the vertical forces and the horizontal forces to determine the other members. Okay, so that's it for this question. I think this is the most simplest among the 3 tutorials I did for you, the revision. Okay, the revision we did. So if you have any difficulties, you can always ask in the comment section, or if you think I may not reply on time, so you can just meet your colleagues that understood this very well, so that they can put you through. Okay, thank you very much, and I wish you all the best.